presence of defects or vacancies within the O3 type non-NO2 structure influence ion mobility? What external factors such as temperature or electrolyte composition impact the activation energy and ion transport efficiency? How does the phase stability of O3 type non-NO2 affect its ability to sustain efficient sodium-ion transport over multiple cycles? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What insights can be gained from computational modeling or experimental studies regarding the activation energy barriers in O3 type non-NO2? How does the comparison between O3 type non-NO2 and other layered oxide materials inform future research directions for optimizing sodium-ion transport? Are there alternative cathode materials that offer lower activation energy requirements while maintaining high electrochemical performance? What lessons can be learned from lithium-ion battery cathodes regarding activation energy and ion transport mechanisms? How do advanced characterization techniques such as X-ray diffraction or electron microscopy help in understanding the structural evolution of O3 type non-NO2? What emerging research strategies focus on overcoming the activation energy limitations of O3 type non-NO2 for practical sodium-ion battery applications? How do transition metal elements with 3D orbitals ranging from T to Ni function as high-activity sites for sodium storage matrices? What specific properties make Fe and Mn effective for sodium-ion battery cathodes, and how do other transition metals compare? How do layered oxides contribute to the electrochemical performance of sodium-ion batteries, and what advantages do they offer? Why are layered NaCsCoO2 materials among the first to be studied and applied as primary sodium storage materials? How does the structural composition of NaCsCoO2 influence its sodium storage capabilities? What are the differences between O3 and P2 layered structures in NaCsCoO2, and how do they affect electrochemical reversibility? How does the simple preparation method allow NaCsCoO2 to obtain both O3 and P2 layered structures? What mechanisms enable the electrochemical reversibility of sodium storage in these layered oxides? How does the sodium-ion transport process differ between O3 and P2 structures, and what impact does this have on battery performance? What role does the crystal structure of NaCsCoO2 play in determining its efficiency as a cathode material? How do phase transitions within NaCsCoO2 affect its cycling stability and long-term performance? What are the key advantages and limitations of using NaCsCoO2 as a sodium-ion battery cathode? How does the interaction between sodium ions and transition metal sites influence the electrochemical behavior of NaCsCoO2? What external factors such as temperature or electrolyte composition impact the stability and performance of NaCsCoO2? How do synthesis techniques affect the final electrochemical properties of NaCsCoO2?